Section 1.7, Properties of Real Numbers. The first property that we will discuss is called the commutative property. The commutative property allows us to change the order of addition or multiplication. In other words, if we have a sum of two numbers, a plus b, it is known that that is equivalent to the sum of b and a. Similarly, the product of a and b is equivalent to the product of b and a. We are allowed to switch the order in addition or multiplication. So how can we apply the commutative property? This exercise asks us to use a commutative property to rewrite the expression. Do not simplify. So for example, -3 times 7 is the same as 7 times -3. Again, it says do not simplify, so we will leave it as is. -3/4 plus -5/12 is the same as -5/12 plus -3/4. We are allowed to change the order of additions or multiplications. Finally, a times 23 is the same as 23 times a. And remember that when we see something like this, 23 times a, we usually do not write the multiplication dot. Rather, we simply write 23a, and the multiplication is understood. The second property we will discuss is called the associative property. The associative property allows us to change grouping in a string of additions or multiplications. So if we have an intended grouping of a plus b and then add c, we can instead add the b plus c first and then add that result to a. We have a similar idea for multiplication. It allows us to change groupings. Again, let's use the associative property to rewrite the expression, but again, we do not want to simplify. So here we have -7 plus the quantity 5 plus 15. So we have additions, and again, this is important, we must have additions. We can rewrite this as -7 plus 5 and then plus 15. Where notice I've changed the grouping. I have the -7 plus 5 being added here first. Here we have in grouping 9 times -4 and then multiply that by 5. This is the same as 9 times the quantity -4, and I'll put that in parentheses, times 5. In the third example, we have 5 times the quantity x times y. This would be the same as 5x times y, where notice I've written the 5 times the x without the multiplication dot. So those are the associative properties. Next we have the distributive properties. What this tells us is that if we have a number being multiplied by the sum or difference of numbers, that number on the outside can be distributed into each of the terms within the parentheses. So a multiplied by the quantity b plus c is a times b plus a times c, and similarly a times the quantity b minus c can be written as a times b minus a times c. So here we are asked to use a distributive property to rewrite the expression, then simplify the expression. 3 multiplied by the quantity x plus y. Well, that would be the same as 3 times x plus 3 times y. And we can simplify that by simply writing 3x plus 3y. Negative 1 by the quantity a plus 6 can be written as negative 1 times a plus negative 1 times 6. Negative 1 times a can be written as negative a plus negative 1 times 6 can be written as negative 6. Now we usually don't like to write negative a plus negative 6. Instead we would write negative a minus 6. "12 subtract the quantity 4u minus b." Now here, even though it's not written, it is understood that there's a 1 in between that subtraction and the quantity. And so what we're doing is we're subtracting 1 times the 4u minus b. So this is the same as 12 plus negative 1 times 4u minus b. Now we can distribute that negative 1 through the quantity. So that would become 12 plus negative 1 times 4u minus negative 1 times b. Negative 1 times 4u is negative 4u. So that's 12 plus negative 4u. Negative 1 times b, so now we have minus negative b. And again, in practice, we usually wouldn't leave this as plus a negative. Adding a negative is the same as subtracting. So we would write instead 12 minus 4u, and then we'd have minus negative b, and again, we don't usually write minus negative b. Instead, we would write plus b. Subtracting a negative is the same as adding. Now, in practice, in these last couple examples, in practice, what we would generally do is we would take this negative and apply it to each term. So we have this negative 1 times a is negative a. Negative 1 times a plus 6, and negative multiplied by a positive is a negative, and we write minus 6. Similarly, on this example, I would have had the 12, and now the negative distributed to the 4u would become a minus 4u, and the negative distributed to a minus b, subtract a negative, or multiplying a negative times a negative is a positive, and so I would write plus b. So let's apply the distributive property to rewrite the expression, then simplify the expression. Now it would be a good time to pause and try these on your own. Alright, so we have x plus y times 7. Well, using a commutative property first, that is the same as 7 times x plus y. I've simply changed the order. Now applying the distributive property, that's the same as 7 times x plus 7 times y, or more simply, 7x plus 7y. Applying the distributive property, well actually, let's leave the 4x alone. Now what I'm going to think here is I have this negative 2 that's being distributed into both terms. So negative 2 times 3y would give me a minus or negative 6y, and the negative 2 times the negative 5 would give me a plus 10. Now let's use the distributive property sort of in the other direction to insert parentheses and use that to simplify the result. 2b plus 8b. Well, it might not look like there's any way to apply the distributive property. This would be the same as the quantity 2 plus 8 times b. If you think about the first example on the previous slide, that's pretty much what we had. But now 2 plus 8, I can simplify that. 2 plus 8 is 10. So I have 10 times b, or more simply, 10b. Now would be a good time to pause and use a similar process on these next two examples. Negative 2x plus 5x would be the same as the quantity negative 2 plus 5, close the quantity, times x. Negative 2 plus 5 is 3, and so we'd have 3 times x, or more simply, 3x. 4y minus y, now here we have to be careful. There's an understood 1 here. So this would give us quantity 4 minus 1 times y, or 3 times y, or more simply, 3y. The next properties that we will discuss are the identity and inverse properties. The identity properties tell us that if we add with 0, we get the same number back. Similarly, if we multiply with 1, we get the same number back. Any number plus 0 is that same number. 0 plus any number is that same number. Similarly, any number times 1 is that same number, and 1 times any number is that same number. The inverse properties tell us that if we add any number and its opposite, the sum is 0. So we saw that property earlier, but we didn't give it a special name. Now we give it the name inverse. Any number plus its opposite is 0. Also, the product of any non-zero real number a and its reciprocal is 1. Any number multiplied by its reciprocal is 1. So here are some examples and we are asked to state the property or properties that are illustrated. Alright, so first here we have this 5x plus 0 is 5x. Well, what are we doing? We're adding with 0. 5x plus 0 is 5x. This is an identity property. And actually, this next example, 1/7 times the quantity 7a equals 0, is incorrect. That 0 should, in fact, be an a. So now let's look at it in its correct form. What properties are used here to show that 1/7 times 7a is the same as a? Well, actually, there's two properties I can think of. The first property is really an associative property. Because what we're going to do here is I can rewrite this as 1/7 times 7 times A. So there's the associative property. Now 1/7 times 7, hey, that's an inverse, because now that's the same as 1. And now an identity. 1 times A is A by the identity property. So in going from the initial statement, looking at the left-hand side, the initial statement to the first step, I used the associative property, and from there to the second line, I used an inverse, and to get to the third line, I used the identity property. Now this next one's kind of tricky. 5/4 is the same as 5/4 times 10 over 10. Well, wait a second. Isn't 10 over 10 just 1? 10 divided by 10 is 1. So really what I'm doing here is I'm taking 5/4 and I'm multiplying it by 1. That's an identity property. So to go from 5/4 to 5/4 times 10 over 10, I'm using an identity property. And then to go from 5/4 times 10 over 10 to 50 over 40, that's not really a property, that's just our rule for multiplication of fractions. One over y plus negative 1 over y equals 0. This one's a little tricky. It looks like maybe I'm using a reciprocal of something, but I'm not doing any multiplying. I'm adding, and I'm adding numbers, I'm adding opposites. I'm adding opposites and getting 0. That is an inverse property. And more specifically, the inverse property of addition. So sometimes these properties are useful in calculations, particularly if you don't have a calculator handy. How can we calculate 4 times 1,726 times 25? Now, of course, if you have a calculator handy, it's not difficult at all. And you could, of course, use the long multiplication methods you've learned in the past. But what I'd like to show you is, if we think about it a little bit, there are some ways that we can approach certain operations that might be more beneficial if we understand the properties. So I've got 4 times 1,726 times 25. Well, what if I rearranged and regrouped things a little bit? So let me rearrange this as 25 times the quantity 4 times 1,726. So there I've used a commutative property. Now let me change the grouping to 25 times 4 in quantity times 1,726. Now I've done this because I know that 25 times 4 is a nice number. And I used an associative property to get there. 25 times 4 is 100. And multiplying a number by 100 is usually pretty easy. If it's a whole number that we're multiplying by 100, all you do is add 2 zeros to the end. $134 times 7. Now this one's not as nice, but let me write it as 7 times 134. Now 134 really means 100 plus 30 plus 4. Applying the distributive property, I have 7 times 100 plus 7 times 30 plus 7 times 4, which is 700 plus 210 plus 28, and now the addition is fairly simple, and I get 938. So that's sometimes how people do multiplications in their head. They think of it as really a distributive property and then add the pieces back together. Sorry about this. I don't know what's going on with my computer here. Alright, I'll do the best I can with this. 4,573 subtract 997. You might say, well, that's just a simple subtraction. But let's think about this a little bit. That's pretty close to 1,000. In fact, 997 is the same as 1,000 minus 3. So now if I apply the distributive property, I can write this as 4,573 subtract 1,000, add 3. Right? Subtract 1,000 and then subtract and negative 3 is the same as adding 3. Well, that is 3,573, and then add 3 is 3,576. So when I see a number close to 1,000 or close to 100, I tend to think of it as adding or subtracting a number close to 100, and then I tend to use the distributive property to help me do those subtractions. Now we have 1/2 by 4/5 by 7/3 by 2 by 5/4. Well, that looks really messy. But let's rearrange it and regroup it. So why don't I write it like this? Using commutative properties, maybe repeatedly, I can write this as 1/2 times 2 times 4/5 times 5/4 times 2. So that was just using commutative properties. Now, let me regroup this as 1/2 times 2 times 4/5 times 5/4. And, sorry, that shouldn't have been a 2 there. That should have been a 7/3 times 7/3. Now notice I've got 1/2 times 2. Well, 1/2 times 2 is 1, because they are inverses. 4/5 times 5/4 is 1. And then 7/3 is still 7/3, and 1 times 1 times 7/3 is 7/3 by the identity property. So if you know these properties, you can sometimes use them to help you with calculations.